sines is what we use when we don't have a right triangle. Because right triangles are really handy. You can use Pythagorean theorem. You can use all this cosine, sine, and tangent. You can use 30, 60, 90 triangles. All this stuff goes with right triangles. But what happens if I want to find out a side of a triangle and it's not a right triangle? I don't have any of that stuff to use. So the smart old guys figured out the law of sines. And the law of sines works with any triangle. All right? And the law of sines just says that the ratio of the sine of the angle compared to its opposite side, so angle A goes with side A, angle C goes with side C, angle B goes with side B. The ratio of this angle to its side is the same, it's going to end up being the same number no matter which angle and side you pick. Okay? So think back to Algebra 1 in geometry. We've got ratios here, so if we set two of them equal to each other, we've got a proportion, and if one of these is missing, we can cross multiply and solve for the missing one. All right, so let's put one of these, try one. I think that's the easiest way. Let's move this all up. Okay, oh, and one other thing, you can use the law of sines when you have two angles in a row and a side, or angle, side, angle. Okay, so like this one is, up here is angle, angle, side. So you can use a law of sines. You have angle, angle, side, angle, or side, side, angle. Okay, so you have two sides in a row and then the angle. So that's when you can use law of sines. If you can't use law of sines with any other combo of sides and angles. And that becomes pretty clear because when you go to set up your proportion, you'll have too many variables. And so you won't be able to use it. So, that's good to know, but you will also just not be able to do it if you don't have those things. All right, so let's try to solve for x. So given the ratio that the sine of the angle over its opposite side. So in this first one, it would be the sine of 105 over 18 is equal to, and what's going to be the ratio over here?
Sine 32.
Right. Right. Sine of 32 over x. Okay. Then I cross multiply. So I get x times the sine of 105 is equal to 18 times the sine of 32. Okay? So I'm going to multiply 18 times the sine of 32, then I'm going to divide both sides by the sine of 105. So let me do that real quick. So I do 18 times the sine of 32, and then I divide that by the sine of 105, making sure I'm set for degrees. Make sure you are, because if you're in radians, you're going to get a different answer. So you multiply, check me? You go to mode, and then make sure that the degrees is highlighted. Okay? And especially right now, because we're going to be moving back and forth between degrees and radians, so you need to make sure you have it set the right way. Okay, so I get 9.9, and that means this side is 9.9. Okay? Now, if I want to find the other, this angle and this side, first of all, how would I find this angle?
Take 105 and 32 and subtract 180.
Yeah, exactly. I don't have to do anything fancy. I can use the sum of internal angles of a triangle. So I add 32 plus 105, that's 137. I subtract it from 180, and I get 47. Okay? Now, how would I find that side? Do what? You can't use Pythagorean theorem because it's not a right triangle. Yeah, exactly. Let's just do the same thing. So I'm going to do sine of 105 over 18 equals sine of 43 over y. Okay, so I do 18 times sine of 43, divide by sine of 105. Okay? All right, so I do 18 times sine of 43 divided by sine of 105, and that gives me 12.7. What, did I use it wrong? The internal angles of a triangle always equal 180, so we just subtracted. So I get 12.7. Okay? Make sense? All right. Now, it's a little bit different when I have an angle missing, because I'm going to have to use inverse at the end, but the original problem sets up the same. So somebody give me the ratios. Give me the equation I would solve. Sine 50 over 7.6, good, equals, exactly, sine of x over 4.3. Okay, cross multiply and I get 4.3 times sine of 50 equals 7.6 times the sine of x. Okay, so I'm trying to solve for the sine of x, so I'm going to kind of do the same thing. I'm going to do 4.3 times the sine of 50. Okay, that's one side. Now, if I'm trying to solve for the sine of x, what am I going to divide by? 7.6. So I'm going to divide that by 7.6. Okay, and that gives me 0.4334. So 0.4334 is equal to sine of x. So I'm still, x is still caught inside sine. It's not just x equals, it's sine of x equals. So the way I do that to solve for x is I use the inverse sine, because inverse sine gives me the angle instead of the length of the side. Okay? So, and isn't that where the angle would normally go? So I'm looking for the angle, not the side. So I'm going to do inverse sine, which is second function sine. It's the one with a little negative 1 here. So I'm going to do inverse sine of 0.4334, blah, blah, blah. And that gives me 25.7. Second answer. So that gives me 25.6 or 7. Okay? Now, there's one small catch to having side-side angle. The problem is, if I have two sides and an angle, like, so if I have an angle and then two sides, that side could go out like that, right? Okay? But since I don't know this side or how far apart these two are, this side could also swing back and go this way. Okay, same angle, same two sides, but now it swings back this way. So when you're solving law of sines problems, and you're given side angle, you're gonna get two. It's possible that you're gonna get two different answers depending on if you use like sine of A over A equals the other side or sine of B over B equals the other side. So, and it's not one is more right than the other. You're just gonna get two answers. So like on your homework, you'll see two answers. Like some of the answer blanks, instead of just having one answer, there'll be two because when you solve it, depending on which trig function or which side and angle you use, is going to give you a different angle. Okay, it's based on the old hinge theorem, if you remember that from geometry, that it could swing out this way or it could swing back this way. And whenever you only have an angle and then two sides, you don't know. It doesn't freeze it to be able to tell. Okay. So that's when you have side angle, you have to watch for that. You can possibly get two different solutions.
Yes.
Okay. All right.